Mather's internal community, they were going to use Hadoop as a discovery tool for them. They're on an ongoing basis, they want to be able to look at 100% of the data as a big selling point to their client to go back again and again and try and ferret out new nuggets that they might not have already gotten. And so after having gone through the requirements process, we came up with this graphic here. And really, the continuous theme here is that we needed to have an architecture that supported ease of data extensibility and also scalability. And we took a top-down approach from a requirements standpoint rather than starting with the platform. I mean, jumping in at the bottom of this platform and collecting data with no eye towards data consumption, we felt was really bad. And why would you start with capturing the data before you know how it's going to be used? Similarly, jumping into the top of the pyramid without having a broad integrated data platform already, we think was bad. Just thinking out loud, building a dashboard without having a holistic data plan already could lead to you answering a question that doesn't even matter to your business just a little ways down the road. So this siloed data will cause you to lose data taxonomy and definitely could cause stagnated data in fairly short order. So what we ended up having here really are two approaches, and we were going to go through the requirements looking at it through both the Hadoop and the data warehousing lens. And really, after thinking about it and doing some planning, we decided that we really didn't want to go all in with either approach, especially with time being of the essence. There were requirements that were best met by a traditional data warehouse architecture, and some were met by Hadoop. And we really didn't want to sacrifice traditional data warehouse functionality by going Hadoop only and vice versa. So what this led us to was a hybrid approach, and we call it the smiley face because we need everything to come together happily from both worlds. Really, just to kind of step back and talk about data warehousing as well, it doesn't mean the same thing to every company or every person. Often, people think it's just a loosely connected set of relational tables, but when we talk data warehouse here, we're talking like Kimball, dimensions, star schema. So with that, we felt that we really needed to go down the dimensional route to buy ourselves the speed of query and browsing and slicing and dicing that we would get from that. And at the same time, we knew that there were ingestion capabilities in Hadoop that we didn't want to lose out on that you don't get with traditional out-of-the-box data warehousing products. So particularly talking about Mather, they had an abundance of semi-structured and unstructured data. And we really didn't want to lose out on the ingestion capabilities of Hadoop, and we had a cluster in place already. So in melding these two architectures, it became clear that lots of attention would have to be paid to the integration point between these two architectures in order to provide a seamless solution. And this brings us to the implementation pyramid, which really flips our process pyramid upside down, and you start with the data sourcing and work your way down to the dashboard. None of these layers was developed in a vacuum. They were really developed in parallel, and the threads going on in these were across the layers. You can see the vertical lines. Each of these was parallel efforts going on across the layers to meet Mather objectives, and this really helped get things done in a timely manner. And each implementation thread provided a piece of the overall fabric of the architecture. So there's a lot going on in this diagram here, but really this is the entire architecture. And I just put this up here so that you can get some context for the next few slides where we're going to really break this down into slices and talk about each bit of it. So starting on the far left here, you see in the ingestion layer, the data sourcing. And the typical file formats are there, the JSON, the XML, the things that we talked about. But for Mather purposes, this is ad revenue data, this is web traffic, subscription data, customer data. and it's collected by API, FTP, REST calls, and utilizing both push and pull mechanisms. So once we have the data, it's securely stored, and archival for us is like in a rudimentary state for the time being, but we're already looking at Amazon Glacier as like the long haul, much cheaper approach. What we have here now is the next piece of the overall architecture. This is the actual data lake, and it has two purposes to serve here, the internal and the external audience. This piece of the puzzle is fed by an ELT process that's written in Pig and Python, and it works really well. From here, in this section, we do mapping and storage. As you can see, mapping and storage, reducing and linking, segmenting, and it's a blending of structured and unstructured, semi-structured data, all the above. This area gives both a sandbox to internal Mather users to do their data discovery, and at the same time, it operates as the ODS that feeds the data warehouse. So this is really one half of the area that we just got through talking about on the last slide, where this is the integration point. There's the left side, that's the data lake, and then the right side, the data warehouse that we're going to talk about in a minute. And the boundary between the two of them is addressed through Apache Scoop. So the data goes from the data lake into the star schema in the data warehouse that way. So on to the data warehouse. So I just talked with you about Scoop being what goes from the boundary on the data lake to the data warehouse. And Scoop, for our purposes, is the E in ETL as opposed to ELT. Here we're doing traditional data warehousing ETL. We extract data from Hadoop into the star schema. And this is also where we do aggregation and dashboard support and add easy reporting structures for the external users. Conform dimensions are here, change data capture for snapshotting and slowly changing dimensions. And all the measures are pre-vetted and reconciled across dimensions. So this is everything from here is very responsive for an end user dashboard. So all the business logic is encapsulated here, and measured calculation and data cleansing happen here as well, and a strict taxonomy is enforced across the dimensional meanings. So here we have the user interaction layer, and really you see, as we've talked, we have two different audiences. We have on the top of the diagram the internal Mather analysts who are interfacing with this data through HiveQL and Stata and R, and they're doing data discovery against the data lake, as opposed to on the far right, they're external customers who have a vetted experience. Everything is like guided for them already. They can't just run freehand queries from their perspective. Mather has, again, they've vetted everything. There's a single version of the truth, and so that provides for extremely fast queries. So now I'm going to turn this over to Arvid, and he's going to talk more about what Mather has done with this architecture and the insights that they gain from utilizing this solution.
Thank you, Chuck. So really what Chuck and his team built for us, the infrastructure was critical to really, as he said, kind of the internal analyst interaction noted here at the top, as well as the kind of client side on the far right. But again, for us, the goal was to be able to allow, as Chuck said as well, 100% sample size. So meaning that our analysts and economists can actually get into pretty much the raw data over on this left-hand side, where it's perhaps one or two steps away from raw JSON or kind of unstructured, where it's somewhat readable. But that's where we use a lot of HQL and some basics Python as well. But primarily for analysts, again, it's the ability to use Stata and R to build our models and to create the analytics that really guide the last piece in this puzzle, which is the client interaction. And that's where for clients, for our clients at least, there's very little care or interest, unfortunately, in all the what Chuck spent 20 or so minutes going over. But what they really want to have is kind of the actual results and strategy and kind of the clean output. So I won't read this whole thing, but to paraphrase Derek Harris, a lot of companies have oil, they have data, and that's valuable in one sense. But what companies really need is just the gasoline. They need the process, the clean. What do you actually do on a day-to-day basis? How do you make decisions? How do you report on the results? And that's kind of what we as Mather, what we do is to take all of that unstructured data, structured data, all the data sources, and prepare it in a way where we can advise our clients to how to run their business, how to make decisions, but also actually get down into implementation and through traditional data warehousing or traditional ETL processes to actually implement solutions where it's an automated, no-touch process, and there's kind of recommendations or actions being taken without too much human interference. So some of the things that we do that this infrastructure enables us to do is to provide, and I'll talk about some of these in more detail, but one of the primary things we do is something called customer lifetime value, and I'll talk in more detail about that. But it's really about kind of properly assessing the value of each of the customers for different companies and treating them very differently based on their perceived value or relative value to the company. Some of the other things here, this might look familiar, e-commerce flow. So if you think of Amazon.com, it's kind of filling in the shopping cart and going through the steps to purchase. So how do you optimize that? Are there points where people drop off? Are there different segments or different behavioral types that lead to a better conversion, better close rate? For some of our publishing clients, think like NewYorkTimes.com or LATimes.com. It's about optimizing the paywall. So when should you present the paywall to users? At what point in their consumption pattern? And then how do you, what kind of products you offer to them in that paywall? And then how do you again optimize the conversion? So also in the online space, what a lot of firms are doing is advertising targeting. And for us, when we think about this, we're looking at it from the perspective of a company or a firm that actually has advertising inventory to sell. So where, again, if you think of someone like NewYorkTimes.com, they have maybe several million unique visitors per month. They have 100 million pages or more per month, and that leads to maybe 500 million impressions that they can sell in various ways. So what is attractive to some advertisers that New York Times can actually use their own what's called first-party data. And again, going back to the infrastructure that Chuck showed, what we do is we ingest both online behavior, online data, and we kind of segment that and prepare that, but also taking in any offline data. So for example, if it's a registered user, perhaps there's not just the online activity, but also some sort of offline things like perhaps their demographic segment, perhaps their age, their income levels, things like that. And in that case, New York Times, as the owner of all this inventory or of all this audience, can then be very precise in how they sell to advertisers. So if a bank would want to have an ad campaign on the NewYorkTimes.com, they can say, we want to advertise on your site, but we only want people with this income bracket who consume mostly business news, who consume on a regular basis, and with kind of our back-end process, so we can actually prepare that segment for New York Times to sell to the advertisers. Also sticking to the publishing space, editorial. So there certainly is a line of kind of ethics between editorial and revenue, but what we do is kind of give them the tools to actually make those decisions. So if a publisher knows that during certain times of day or certain devices or certain user types, that there's a different type of engagement or different affinity for certain content, they can then publish with that in mind. So if no one's reading sports news, at Tuesday at noon, why publish any new articles? But if Sunday at noon or Sunday at 5 p.m., there's a ton of sports consumption, that's when you want to publish those sports articles. So it's a way of the editorial department side of the publishing industry to, again, be very precise and to maximize the return per article, both in ad impressions and new visitors and potentially paying subscribers through the paywall. The next three here are more on kind of the product side and customer side. So making sure that you can offer the right products to the right people. So if you have different customer segments and different data that informs that, you can give a special offer or a special discount or a special price to different customer groups. For new subscribers, you can have different campaigns and acquisition targeting for, again, to maximize that conversion. And if you're someone with a subscription model, someone like a Netflix or, again, New York Times or any kind of subscription model, you can have retention strategies. So basically, you can prepare or target the people who are perhaps at high risk of stopping and try to preempt that stop, again, using that kind of data. And then lastly, recommendations on content or products. So again, think of, if you go to Amazon.com and you have, they kind of say at the bottom there, people who purchased this product also bought these 10 products. Or same for New York Times. People who read these articles also read this article. So that's kind of really the application of this data. And again, I think the main point that I like to emphasize is that the hybrid approach is really critical because it's without kind of having both technologies at our disposal as analysts and economists, it's very difficult to then deliver to our clients these kind of recommendations where you're kind of giving to them on a platter versus having them to find it themselves. So this is, I know Chuck had a pretty complex diagram, but this is really the simplified view of that same thing and what we show our clients. So at the central point here, you have basically a traditional data warehouse that's at the customer level. And you have a combination of online, usually unstructured data, and offline data. And you also have any kind of customer records or transactions. And some of the things that go into this are, starting at the bottom left, are, again, I mentioned demographics. We have the various customer transactions, so payment history, purchase orders, things like that. At the top right, we have, I mentioned online behavior, so knowing when people visit the site, how frequently, how engaged they are, how many times they come to the site, what products they click and put in the shopping cart but don't purchase, things like that. And then lastly, kind of a very broad thing at the bottom right there, marketing, which is basically any kind of campaigns or kind of targeted emails that perhaps a retailer might send to their customers, and what is the response rate of those things. So if a customer is particularly responsive to certain campaigns or certain creatives or certain offers, that's part of the kind of algorithm in the background that says, customer A, who is in the, mid-income segment, who has purchased before, who is, engaging online every month, and who has responded to this campaign, that's kind of the information that we give our clients access to. But also, us as economists and analysts, we kind of, again, hand it to them on a silver platter. We say, here's what we think is the best way to do it. Based on our econometric models and analytics, we think here's what you should do for your next campaign or your next product offering. So very briefly on customer resolution or entity resolution. So again, this is using traditional data warehousing techniques where you're basically matching disparate records. And the example here would be, not just a one-to-one match, but to apply matching rules and fuzzy logic where you might say that if in two disparate databases, there's a John Smith and a Jonathan Smith, perhaps a traditional, if you're just using a regular match process, that might not match. But if you know that Jonathan is a variation on the name John, and that other records might suggest that that's the same person, there's a 95% likelihood that this person is the same. Therefore, you can reconcile all these different data sources. So again, this is enabled, I think, with a kind of hybrid approach. And then I talked a bit about NewYorkTimes.com, but when a lot of our clients are in the publishing space, and well, I'll explain this really quickly. What this is showing is for a traditional print publication, think a home delivery LA Times or New York Times, again, home delivery paper. And by the way, print journalism is not yet dead, but more on that. But in any case, as they kind of move into the online space, what we're able to do is show the publication that online engagement does make a difference in overall retention. So what we're showing here is over a 26-week time period, people who are receiving a home delivery print publication who have not registered online, they are retaining only at about 84%. So 60% of the customers have stopped if they've never engaged online. Whereas if you get someone to register and engage online, they're retaining almost at 90%. So almost a 6 to 8 point swing in improved retention if you can get a print customer to engage online. So this seems pretty basic, pretty straightforward, but for a lot of print publications, this was revolutionary, where traditionally they only were able to see their own kind of print data, their offline customer transactions, perhaps acquisition channels, things like that, where we brought in a ton of unstructured data through the Hadoop side of the infrastructure, mined that data and prepared it, merged it back to the data warehouse side where we have the customer data, and we're able to show this in a very clean, concise way. And what this means for publishers is that if you can improve retention by even 2 or 3% over 100,000 people, you're saving a ton of dollars in terms of churn and new acquisition. So with that, I'll spend a few minutes on customer lifetime value. And a lot of companies use this. So if you think of this, it's really trying to figure out how to treat different people based on their value to the company. So if you think of, Chuck and I were talking about, we were comparing our mileage status on Delta, and if you're a platinum member, you have a very different experience on Delta than you do if you're a silver or if you're not in the in the SkyMiles program. So if you're a platinum, you get upgraded about half the time. You get the personalized customer service number. You have hardly any wait times if you call them. So it's an example of how companies already are doing this, but it's just a way that you can incorporate as much data as possible using all this infrastructure to build out those segments, all the data that goes into overall customer retention, which is this part in the equation. You, of course, have any kind of costs, variable revenues and costs, so kind of an operating margin per customer. And what you're doing is kind of amortizing that revenue over time, or that op margin over time, based on the expected or predicted retention. So if you remember your integrals or your calculus, basically the area under this curve would be the overall lifetime value for each individual customer. And of course, you can apply various kind of net present value discounting using a discount rate, and maybe a one-time acquisition cost if there is one. So how do you operationalize it? I had a few examples about how airlines do it. Of course, hotels do it. Rental car agencies do it. Any kind of subscription business or business that has customers and revenue can use CLV. But again, the example would be to find kind of various levels of whatever the intervals are, high, medium, low. Maybe there's 4, maybe there's 10. You can use that to prioritize who you email, how you market to them. You can prioritize what kind of products and discounts you give each type of people. So for example, if you're on that cusp of you're not quite profitable, you're almost there, you might just need a little bit to get you profitable. But if you're very unprofitable, perhaps there's a much bigger upgrade that customer needs to make them profitable. I mentioned the customer service. You can have a very different kind of experience when you call customer service based on those CLV segments. And of course, you can overlay that with a lot of other things. So if you have the CLV kind of segments on one side, you can overlay that against demographics traditionally used. You can over psychographics, over content, over products. So there's a lot of ways you can kind of slice and dice different customers based on these segments. And for us, the end goal, using all this data, it's about giving our clients the tools to answer those kind of questions. And this is one example. If you're from the San Diego area, this may look familiar, but this is for a print product that gets delivered to people's homes. And what we were able to show is based on the particular customer attributes that they were after, that they found valuable, that they could actually prioritize and segment the geography of where they deliver, how they deliver, where they prioritize, and how they actually give various campaigns or how they give various discounts and offers based on geography. So here what we found was that the areas in blue were actually some of their high value areas. That's where they wanted to really make sure they didn't lose any customers. The reds were kind of their low value for whatever reason, and they didn't really spend too many dollars trying to deliver there or save those people. And you had kind of the midpoints in kind of the orange and green, where there's various strategies and campaigns that we use to try to get them to upgrade or move into a higher value segment. And then lastly, to wrap up on customer lifetime value and how to actually prioritize this or how to use it, is you basically have a net profit per customer. And if you know this, you can really be precise about, again, what you do with that customer. So most cases, customers are profitable on this side of the chart. But what we find is that as many as maybe 5 or even 10% of certain companies' customers are actually unprofitable. So the question then is, based on the costs and revenues, what do? Do you either have to upgrade them into a higher paying product or higher value product, or if you're not profitable, do you cut it, let them go? So that's kind of the decisions that we help our clients make based on this data. So with that, I'll give it back to Chuck to wrap things up.
So yeah, just to conclude really quickly, data warehousing and Hadoop are not mutually exclusive. There's benefits from using both architectures, and we tried to harness those benefits at Mather by using the best of both worlds. We think their requirements were best met by that hybrid approach as well. We used the ingestion capabilities of Hadoop and the data warehousing, the tried and true at the same time, and we met their needs. And we also feel that the hybrid was the key to satisfying both the internal and the external users. You have two very different audiences here, and the hybrid approach made sure that they could do data discovery, and they could also have very fast queries over HTTP for external users. And last, the speed of the dimensional data really was critical for analytics. Without being able to drill down into the data and slice and dice, we wouldn't have been able to meet the external user requirements. So that's what we've got, and questions? Sure. It all comes through Hadoop. So, I mean, we really are using it as a lake. Everything is coming through there. Sure. That's a really good question. There was a presentation in this room, I guess right before lunch, and I would have liked to have seen it, but where they talk about being able to do insert, update, and delete in Hive. And if that was established, like really tried and true, there's a good chance that we would, attempt to go down that road. But for where we were at the time and not really being able to do insert, update, and delete there, we felt this was the known way to go. I would say that it is custom. We've tried in the past to use a couple off-the-shelf tools, but what's worked best is to get this all into like a dimensional model, and then, as Arvid pointed out, like use fuzzy logic and such in sort of a homegrown application, and that works a lot better. Go ahead. Yes, that's true. So we bring in all of the data untouched into the default Hive database, and then we have individual databases in that layer as well that map like to a client. And so within that, that's where we do munging, cleansing of data, and prepare the data to send over to the data warehouse. So that's the ODS. That's a good question. It just worked best because we had enough expertise at that time to really do it in that layer. If you're from the relational world, definitely doing that sort of thing in a relational database is definitely easier. But again, we had all the data there, we had the expertise to do it. So, sorry. Go ahead. It was the E at the beginning of the ETL, yeah. Yes. I'm sorry? Yes. Anybody else? Go ahead. Your question was, do we do any querying directly? Arvid and his group, they actually do some querying directly against Hive, as part of their discovery.
Yeah, we do. And for our clients, though, it's we try not to give them access to that level of data because it's really granular. It's really, it's not been cleaned up too much. But what we do is when it gets to a traditional SQL instance, we actually allow them to access a level of raw data, either through SQL or just through, like a Tableau or any kind of BI tools. That's kind of how if we do decide to give access to our clients, it's usually pretty cleaned up and through a BI
Right.
tool, or if they really want SQL, we can do that.
All right. Well, thanks for coming, everyone. We really appreciate it.